So one of the things we'll frequently look at is not just one linear equation in several variables, but actually several linear equations at once. And when we do that, what we'll be looking at is called a linear system. So a linear system, often you'll call this a system of linear equations or a system of equations if it's just understood that your equations are linear. You can call it whatever you like. Linear system, system of equations, system of linear equations. All of those mean the same thing. I'll usually use the phrase linear system as I've written here just because it's brief. But all it is a collection of linear equations. So let's write that down and look at an example. Okay, so here's an example of two linear equations in two variables. So the variables will be x and y. So I've got x minus y equals 1 and 2x plus y equals 6. So those are both linear equations in the variables x and y. And just to make it clear that those two equations really are bundled together, I'll draw this bracket, which kind of looks like a bundle. I'm bundling those equations together into one object so I can treat it as one linear system. So I know exactly which equations are in the system. So this is an example of a linear system. And what we're going to do is solve it. So those are our instructions here. And to solve a system of linear equations just means to find an assignment of values to the variables that makes each of the equations true simultaneously. So what values of x and y would make both of these equations true? That's what we're looking for here. So let's tackle this. So I want to show you two different techniques that you can use to solve a system of equations like this. And actually I'm expecting both of them to be somewhat familiar to you. So this should be something you've seen before. Again, it might have been a while. Whether or not it's fresh in your memory, that's another story, but at least you should have seen this at some point before. So the first technique I want to remind you about is the substitution method. Okay, so how would you approach it? Well, what we're going to do is we're just going to pick one of these two equations and use it to isolate one of the variables. And you can pick whichever one you prefer to use in this case. But what I'm going to do is I'm going to take the first equation, which is x minus y equals 1, and I'm going to solve it for x. That just seems to me to be the simplest thing to do. So I'm going to write x equals 1 plus y. Okay, and then what I'm going to do is I'm going to take that expression for x, 1 plus y, and I'm going to plug it in to the x in the other equation. So the 2x plus y equals 6, that's actually going to become 2 times 1 plus y equals 6. Okay, so then there you go. Now we've got an equation with only a single variable. And it's called the substitution method because we substituted this representation of x in for the x in the other equation, and that yielded an equation with one variable, and that's what we can now solve. So first step is just expand the 2 into the brackets, and you're going to get 2 plus 2y plus y equals 6. And if I just subtract 2 from both sides and combine the two terms that involve a y, so this 2y plus y, this will become 3y. And if I subtract 2 from both sides of the equation, I'll get a 4 on the right-hand side. So I'll end up with 3y equals 4, or in other words, I'll get y is equal to 4/3. So now we've determined what the value of y must be to satisfy both of these equations up here. So once you find one variable, it makes it a bit easier to find all of the other variables, or in this case, just the other single variable x. The way we can do that is we can take this value of y, which we've now found to be 4/3, and we can plug it in, well, to any of these equations, but this would probably be the most direct way, right? If we just plugged in our y value here, this is going to tell us exactly what x would have to be. So I'll just write that over here. So we have x is equal to 1 plus y, and I'm just going to carry on with more calculations here and create a chain of equal signs that's going to link x to what its value is going to be in the end. So I'm going to plug 4/3 in for y. So we're going to get is equal to 1 plus 4/3. Now, you could say that that's what x is, but 1 plus 4/3 is not exactly the simplest way to represent that answer. Usually what we would do is we'll just represent it as an improper fraction, so try to combine it all into one fraction. The way to do that is to treat this 1 as a fraction and get a common denominator. So I won't always show these steps in full detail, but for this time, I'll go through the steps carefully just to remind you how to do that in case it's been a while. But I can write 1 as 3/3. So I've got 3/3 plus 4/3. Once I have the two fractions that have the same denominator, I can just add the numerators 3 and 4 to get 7. So I get 7/3. So now we know that x has to be 7/3. And we already knew that y has to be 7/3. So now we can say that the values of x and y, I'm going to write them as an ordered pair with brackets around them separated by a comma. This is writing my solution in point form. I'm going to say the point xy has to be 7/3, 4/3. So that is the way I can summarize my answer as compactly and concisely as possible. It's really important to do this, by the way, because remember, you might have more than 2 variables. You might have 3 or 4 variables. And imagine if somebody asked you to solve a system of equations with several variables, and you just gave them a piece of paper with a whole bunch of calculations and work on it, and they had to now sift through all of your work to try to find little places like this where you had said what each variable was. They wouldn't probably be too happy with you. They'd want you to summarize your conclusions for them. That's part of what you were asked to do. So typically we'll do that. And this is one of several ways to do it. We'll talk about some other ways later on, but for now this is called point form. This is a point form way to represent your answer. This, let me jot that down. This is referred to as point form. Okay, that's one way to solve it. Another way you might be familiar with is called the elimination method. So let's just go back to the beginning and look at a different approach to solving a problem like this. So I'm going to just copy the system down so we have it on the screen. So remember, it was x minus y equals 1 and 2x plus y equals 6. That was the system we had. And I'm actually going to take a moment to number these just to make it a little bit easier to refer to the equations, because with the elimination method, you're going to need to refer to the equations that you're given in your system. So one of the things you notice is that in the first equation, the term that involves y is a negative y. And the term that involves y in the second equation is positive y. So what would happen if I took the equation 1 and I added it to equation 2? What would that give me? Well, this is what it would yield. You can just add all the terms one pair at a time. So just add the x terms together first. So x plus 2x. Well, if you have 1x and you're given 2 more, you're going to have 3 x's. So we've got 3x. If I add the negative y and the positive y, well, think of it this way. If I give you a y and then I take away that y right afterwards, you're left with nothing. So the positive y and the negative y just cancel out and they give you nothing. And the 1 and the 6 on the other side of the equation add up to 7. So you get 3x is equal to 7. And again, you've now got a nice equation with only one variable. I can solve this for x, and this will give me x is equal to 7/3. Now, so that's now given me one of the variables. I've got x is equal to 7/3, and then I could use substitution to figure out what y is. I could take x equals 7/3 and plug it into x in the second equation, or I could plug it into x in the first equation, whichever one I like, and either one would lead me to the solution, because it would give me an equation with only y that I could then solve for y and figure out what y would have to be. So for example, I could take equation 1 and say 1 becomes, well, it would be 7/3 minus y is equal to 1, right? If I plug in x equals 7/3 for x, then I'm going to have this equation, and I can solve it for y. I can add y to the other side. I can add y to both sides of the equation, and I'd get 7/3 is equal to 1 plus y, and then I could subtract 1 from both sides of the equation to get the y all by itself, and I'd have 7/3 minus 1 is equal to y, and then finally I could do a similar trick if I just scroll up. Similar to how I work things out over here, I can get a common denominator between these two fractions, because 7/3 minus 1 can be written as 7/3 minus 3/3. And then I can, now that I have two fractions with the same denominator, 7/3 and 3/3, I can just subtract the numerators and I get, I just get 7 minus 3, which is 4, so I'd have 4/3 is equal to y. So now I've got a value for x, and I've got a value for y. We're typically done now, but we would still want to summarize it in point form. So I could say, well, write it wherever you like, but I could say, therefore, now my final answer, if I choose to write it in point form, my value for x is 7/3, and my value for y is 4/3. So notice that the approach was a little bit different, but the ending is identical, right? You're still going to summarize your answer in the same way, no matter what. So I'm still going to summarize all of my values for the variables, but the approach is a little bit different. So this is two ways that you should be somewhat familiar with: the substitution method that we did up here to get the answer, and then the elimination method, which we did down here. They're not quite identical, but they give you the same result. They're both valid methods. And next, what I'd like to do is show you a third approach, and which will more typically be the approach that we use in this course.